Hello friends, this is new video series. In this video, I explain the short note about numerical analysis. So let us start this new video. Hope you enjoy this video, and if you enjoy or learn something, then please subscribe my channel. So let us start. First of all, errors. The numerical analysis start from errors. So first, what is error? Error means this one is the true value minus approximate value, and another term relative error, which is equal to error mod by true value mod, or absolute value of error by absolute value of true value, and absolute error is error mod. And what is the value of percentage error? Then percentage error is relative error into 100. This gives us the percentage error. Complete. Now come to transcendental and polynomial equation. So here a number xi is a solution of fx equal to 0. This one is a polynomial, transcendental or polynomial equation, that is fx equal to 0. If f of xi equal to 0, such a solution xi is a root or 0 of fx equal to 0. That means here the number xi is called the 0 of fx. Complete. And this polynomial fx is 0, or this can be other term is root. Similarly, if we want to find the what is the order of that 0, then if we can write this fx as x minus xi to the power m into gx equal to 0, where gx is bounded and g of xi not equal to 0. If xi is the root and g of xi not equal to 0, and x minus xi to the power m, this quantity happens, or we can break down this fx in terms of this quantity, then xi is called multiple root of multiplicity m. That means this xi has multiplicity m. Here f of xi equal to f dash of xi equal to f double dash xi equal to, and so on goes to f has m minus 1th derivative at xi point. This gives us 0, and f has mth derivative at xi, this not equal to 0. That means if this condition satisfied, then this xi is called this has the multiple root of multiplicity m. That means xi has multiplicity m. Clear? Now come to bisection method. So here I did not explain the complete bisection method, but in bisection method there is a formula for finding how many steps are required for bisection method for a particular error bound. Then this formula is very useful formula. So let us discuss this quantity. And here this formula says that if the permissible error is epsilon, that means we have the permissible error constant is given, and this error constant is epsilon, or how many up to how much decimal roots we want to find, this much is epsilon. Then this formula gives us n is greater than equal to log b0 minus a0 minus log epsilon by log 2. Clear? And here a0 is the starting point and b0 is the ending point, because in bisection method there is some a0 value and another is b0 value. So starting one is a0 and another one is b0. Since n is integer, as we want to find how many steps, that means these steps must be the integer value. So we take as the next nearest integer value. So this expression gives us a fraction value or decimal value. Then we approximate this value as the nearest integer value, and this one is the gives us the solution. Clear? And how these methods work? So this method, it is based on the repeated application of the intermediate value theorem. Clear? In this one is also a short question type question. So bisection method is based on repeated application of the intermediate value theorem. Clear? And what is the intermediate value theorem says? So here the statement of this intermediate value theorem is, this one is also a short question type question. Sometimes they can ask what is intermediate value theorem, or and 4 bit are given and questions are sets. So here let us look at this theorem. If fx is a continuous function on some interval, closed interval ab, here a is the starting point and b is the terminal point, and f of a into f of b is less than 0, then the equation fx equal to 0, that means fx is the root, has at least one root or an odd number of roots in the interval, open interval ab. Clear? So this is the statement of that theorem, and here I did not provide the complete proof of this theorem, only I explain the statement of this theorem. So here this statement says that fx equal to 0 has at least one root or an odd number of real roots. This one root or odd number of real root, this one is creates a short question type. Clear? So remember this thing. Now come to second method. Here I explain the iteration formula for second method. So for detailed explanation of second method or what is second method, you refer to books. Here only short note, that's why I provide only iteration formula. Similarly for regular policy this one, and Newton option is this much. So here let us say what is the second method. So xk plus 1 this equal to xk minus xk minus 1 divided by f of xk minus f of xk minus 1 whole quantity multiplied with f of xk, where k value lies or takes, this k value takes 1, 2, 3 and so on. Clear? Similarly, now for regular Falsy method, this xk plus 1, this gives xk minus 1 into f of xk minus xk into f of xk minus 1 divided by f of xk minus f of xk minus 1. Here also k goes from 1, 2, 3, 4, 5 this much. Clear? And similarly for Newton-Raphson method, this Newton-Raphson method iteration formula gives us xk plus 1, this is equal to xk minus f of xk by f dash of xk. Clear? This f dash means derivative of f at that point xk. Clear? And this k value lies from 0, 1, 2, 3 and so on. Next, rate of convergence. So first of all, let us looks about what is the definition of rate of convergence. That means if we apply a iteration formula or iteration scheme, then how quickly or how fastly this formula approaches the root. This gives the rate of convergence. So let us find first of all the definition that says that an intermediate method is said to be of order p, or an iterative method, not intermediate. An iterative method is said to be of order p or has an rate of convergence p if p is the largest positive real number for which there exists a finite constant c not equal to 0, such that this epsilon k plus 1 mod is always less than or equal to c times epsilon k to the power p, where this epsilon k equal to xk minus xi is the error in the kth iterate. That means if we this iteration method is given, then in kth iteration this epsilon k equal to xk minus xi is the error. Clear? So here the constant c is called the asymptotic error constant and usually depends on derivative of fx at x is equal to xi. Clear? So this gives the definition of rate of convergence, and if we want to find the second method or what is the rate of convergence for second method, here the value of p equal to 1 plus minus root over of 5 divided by 2. Here we neglect the negative sign and we take only positive sign. So the complete proof is given in, so in this case only I give the exact value of that second method is rate of convergence. This is equal to 1 plus root 5 by 2. Sometimes this will ask in question or sometimes this. So this value is 1.618. Also for now come to regular Falsy method. So regular Falsy method has p value equal to 1 or rate of convergence is 1. Similarly, Newton-Raphson method has rate of convergence is 2, and another method, that is Muller method. Here rate of convergence p equal to 1.84. Clear? And the CVC method, here p equal to 3. Here the rate of convergence is 3, but in CVC method a very big calculation is required for converging this value. So mm, so for a remembering point of view, we can only remember p equal to 3. Okay, so if you like my videos, then comment me please, so that I can continue my lecture series. So thank you.